Hey everyone, today we are going to review linear and compound inequalities. This is stuff we did way back in first semester. So this first example, very straightforward problem, one that is solved just like you would solve an equation, right? We want to get the variable by itself. So we're going to do the opposite of subtracting 8, which is we're going to add 8 to both sides. And that's going to give us x is less than 3. Negative 5 plus 8 would give me 3. Okay, so if I'm going to put that on a number line, right here's my number line, and again, it doesn't have to be anything fancy. 3 is my starting point, so I'll put that right in the middle of my number line, and then I'll write a couple points below it and a couple of points above it. And it's less than, it's not less than or equal to, and because it's strictly less than, I'm going to make sure I have an open circle at 3. And because it's less than, I go left, right? Less than means we shade to the left. And so that is what our solution would look like on a number line. Now I say less than and left because that variable, I always want to read it so that the variable is on the left. It's just going to make your life a lot easier. So recognize that x is less than 3 is exactly the same as saying 3 is greater than x. So notice I just switched the order of my terms and I flipped the sign. So when you're looking at problem number 2, in this one, the variable is on the right. I don't like working with it when it's on the right. I much prefer it to be on the left. So I'm actually going to rewrite this problem. So I have the absolute value of x plus 2, and I'm going to flip my inequality is greater than 3. So because I switched the order of my terms, I also have to switch that inequality. This example is an absolute value inequality. And whenever you have an absolute value inequality, you're going to set up 2 inequalities in order to solve it. Okay, the first one, you're just going to take it out of the absolute value symbols and leave everything else exactly the same. And in the other inequality, you're going to take it out of the absolute value symbols. You're going to flip the inequality and you're going to change the sign or negate that other side. So the first inequality is just take it out of the absolute value symbols, leave everything else the same. The other one, take it out of the absolute value symbols, flip the inequality, and change the sign of the other side. Now you just have 2 very straightforward linear inequalities to solve, right? So over here, I'm just going to subtract 2 from both sides, and I'm left with x is greater than 1. Over here, I'm going to subtract 2 from both sides as well, and here I'm left with x is less than negative 5. So here I have 2 different solutions to the same problem. So I want to make sure that I capture both of those on my number line. So here's my number line. And let's see, I've got negative 5 over here, and positive 1 is going to be somewhere over here. Notice I'm not really putting any numbers in between them. I don't need them. I just need those values that I just figured out on my number line. And you have to make sure you put them in the right order. Negative 5 is less than 1, so it has to be to the left of 1 on the number line. Okay, so now I'm going to go ahead and put both of these inequalities on this number line. So I'll start with this one. X is greater than 1. Well, here's 1. It's greater than, so I have to have an open circle, right? Because it's not greater than or equal to, it's just greater than. And because it's greater than, I go to the right, right? So I shade to the right. For the second one, x is less than negative 5, so I have an open circle at negative 5. Less than means go to the left, less than left. And there is the solution to that part of it. So I have my solutions going away from each other. That means my answer has an or in it, right? Because I can't satisfy both of these conditions at the same time. Because there are no numbers in the universe that are less than negative 5 and greater than 1 at the same time. So I have to have an or in my answer. So this whole thing is my answer. and this whole graph is my solution set when I graph it. Okay, let's go on to a few more examples. In example number 3, you'll see that they already have the OR in the problem. So we already know most of what we have to do. I just now need to solve this other side of it, right? This one's already solved. I need to solve this. So I'm just going to divide both sides by 3. And when I do that, I end up with x is less than -2. So again, if I create my number line, and I put these two values on it, right? So if I've got -2 and +5, if I'm greater than or equal to 5, that means I actually would have a closed circle at 5. And greater than means I shade to the right. And then less than -2 means I have an open circle at -2. And I shade to the left, less than left. That's what my solution set looks like on a number line. So I didn't have to do anything with that x is greater than or equal to 5. I did, however, have to solve for x in that other inequality. Okay, another example of a compound inequality is when you have it all kind of written as one giant inequality. So I'm just going to rewrite it to start. So we've got 9 is greater than 2x minus 1 is greater than or equal to -3. Now, what I like to do with these is I like to actually split them up into two separate inequalities. I think it's going to make your life a lot easier. So the first inequality I want to look at is I want to take all of this first, and I want to look at that inequality, right? So that would be 9 is greater than 2x minus 1. Now again, I don't like having that variable on the right, so I'm going to flip this whole inequality around. So I'm going to actually write it as 2x minus 1. Because I'm flipping the order, I have to flip the inequality. And that leaves me with 2x minus 1 is less than 9. Okay, let me go ahead and solve that, right? I'm going to add 1 to both sides. And that leaves me with 2x is less than 10. If I divide both sides by 2, I get x is less than 5. So that's part of it. The next part is I'm going to take that middle part again and now do the inequality kind of on the other side, right? Because I'm breaking this up into two separate inequalities. So that would leave me with 2x minus 1 is greater than or equal to -3. And I don't need to switch the order of these because my variable is on the left already. And so when I go ahead and solve this inequality, I'm just going to add 1 to both sides. And that leaves me with 2x is greater than or equal to -2. And then I'm going to divide by 2. And that leaves me with x is greater than or equal to -1. Okay, so now let's go ahead and graph our solution set. And you might be thinking, oh, they're separate inequalities, so there must be an OR in there. Okay, I can't assume that there's an OR in there until I look at my graph. So I've got -1 and I've got 5. And when I go ahead and graph those, let me start with this one here. X is less than 5. So if x is less than 5, that means I have an open circle, and less than means I go to the left. So I would be shading this way. Okay? And the other one is x is greater than or equal to -1, which means at -1 I have a closed circle because it's greater than or equal to. And because it's greater than, I'm shading to the right. Now, normally you'd see me put arrows and things, but this time I didn't put any arrows. And the reason is this. I have endpoints that I'm shading between, so I don't need to put the arrows because everything is between those two values that's being shaded. If you notice here, I shaded on the outside of the values, so I had to have those arrows to indicate it goes on forever and ever. But here, It's just going up to that other point, so I don't need arrows. Okay, so this would not be an OR because I do have numbers that satisfy both conditions at the same time. So you might write this as an AND, or it could be written as -1 is less than or equal to x is less than 5. So you could write it like this, or it could be written like this, but either way the graph is the same. It's shaded between those two values. Okay, our last example is another absolute value, except this time it's an absolute value in a compound inequality. So I'm going to kind of combine two things together. The first thing I'm going to do is split it up just like we did in that last problem. So I'm going to start with this part first. Okay, so that gives me the 6 is less than the absolute value of x plus 1. Okay, again, I don't like having the variable on the right, so I'm going to flip this around. Absolute value of x plus 1 is greater than 6. Now, I have an absolute value inequality, so I set up my two inequalities. X plus 1 is greater than 6, and x plus 1 is less than -6. Okay, so again, take it out of the absolute value and leave everything else the same. And in the other one, take it out of the absolute value, flip the inequality, and change the sign. So when I solve these, I get x is greater than 5, and here I get x is less than -7, right? Because I'm subtracting 1 from both sides. So if I were to put that on a number line, that would give me -7 and 5. I'm greater than 5, and I am less than -7. So that's one part of it. Okay, I still need to go ahead and do the other part, which is this part of it. Okay, so when I do that, I have the absolute value of x plus 1 is less than 8. Again, I have to split it up. So I have x plus 1 is less than 8. X plus 1 is greater than -8. So when I solve this, I get x is less than 7. And when I solve this one, I have x is greater than -9. Go ahead and draw your number line. Here's my -9. Here's my 7. I'm saying I'm less than 7. I'm shading this way. Less than is to the left. Greater than -9, so I'm shading this way. So because I'm shading between them, I don't need arrows. It's just all connected right there. Okay, that's all connected right there. This last part's a tiny bit tricky. Here's the idea. I have all these different things going on. Okay, I've got this situation over here. I have this situation over here. So how do I combine that into one large graph, right? Because I need to put everything together in one graph. Well, look at what you have here. Look at your two leftmost values. I'm less than -7, but I'm greater than -9. So I have -7 and -9, and I'm pulling those values that are between those. And then on the other end, I have 5 and 7. So I have 5 and 7. I'm greater than 5, but I'm less than 7, which means I'm shading between those as well. And so this is my final solution where I've taken both of my inequalities, compared them. I looked at the two leftmost numbers and I looked at the two rightmost numbers and kind of combine them into a single inequality. Hopefully that helps. These problems are going to be just like the ones you'll see on your assignment, and we'll see you next time. Thanks, everyone.